Good day to you all, and welcome to Math Marathon class. So, like I promised in the last class, that we are going to start with the simplification of rational fractions by linear combination and factorization method. So, we'll be looking at how to do it and with example. Now, this involves fractions that can be combined together as a single fraction, either by reducing the terms to its simplest form, or by LCM, or both. Now, how do you find the LCM? It says the LCM is the product of the factors when they are different. Like if they are different factors, we take the product as the LCM, and then one of the factors when they are the same. If the denominators, that means the denominators are the same, the LCM is one of the factors. Or the highest multiple when one factor is the multiple of the other. Of course, you take the highest multiple when the two denominators, when one of the denominators is the multiple of the others. So let's take an example. So we have 3 over 2x minus 1 plus 2 minus x all over x minus 2. Now we look at the denominators. They are not the same, 1, and 1 is not a multiple of the other 2, so they are different denominators. So what do? We take their product as the LCM. So we have 2x minus 1 into x minus 2 at the LCM. Now, if this one divides this, we are left with x minus 2. So 3 times x minus 2, and then plus. If this one divides this, we are left with this. So this times this. So we have 2 minus x into 2x minus 1. Right? Yeah. So let's open the bracket from the numerator. So 3 times x, we have 3x, and 3 times minus 2, we have minus 6. So coming to this side, we have plus 2 times 2x, we have plus 4x, and then plus 2 times 1, we have minus 2, and then minus x times 2x, we have minus 2x squared, and then minus x times minus 1 is plus x, right? Then all over, we still have 2x minus 1. We leave this one like this first, by x minus 2. Now from the numerator, we collect like terms. First of all, we have this one, which is minus 2x squared, right? Now we collect for x. We have 3x plus 4x plus x, which is 8x plus 8x, and then minus 6 minus 2, which is minus 8, all over 2x minus 1 into x minus 2, right? So what do? We factor out from here. Of course, 2 can just divide the whole thing, but let's just factor out 2. When you factor out minus 2, we have x squared plus minus 4x, and then plus 4. Yeah, when you factor out minus 2, of course, we have x squared, and then that 2 is 8, we have 4. That's 4x with minus. So when this minus multiply this minus, it becomes plus, and then plus 4. So that no minus multiply it becomes minus, all over 2x minus 1 into x minus 2. Now let's factorize the numerator. So for this one in the bracket, we look for two numbers which when we multiply, will give us 4, and when we add, it gives us minus 4. And the two numbers are minus 2 and minus 2. That is minus 2 and minus 2. But if you add minus 2 and minus 2, it will give you minus 4, and when you multiply, it gives you 4. So we have into x squared minus 2x minus another 2x plus 4, all over 2x minus 1 into x minus 2, right? Now, this is the same thing as minus 2 into factorize. This is x into x minus 2, and this place minus 2 into x minus 2 all over 2x minus 1 into x minus 2. Of course, you know how we factorize this one. When we bring out one x, we will be left with x and the minus 2. And coming to this one, when we bring out minus 2, we'll be left with x and the minus 2. So that when this minus multiply this minus, when this minus multiply this minus, it gives us plus. So this is, we have now that minus 2 into, but we have x minus 2 and another x minus 2 all over 2x minus 1 is equal to 2x minus 1 into x minus 2. And from here, what do you notice? Notice that this one, this x minus 2, we cancel one x minus 2. And finally, we have that this is equal to minus 2 into x minus 2 all over 2x minus 4. And this is the final answer. So this is one of the questions, which of course we've used this the first method of looking for the LCM. That means when the denominators are different, so we take the product of the denominators. That is the one we used to solve this one. Now in our next class, we try another method where we have either similar denominator or when one denominator is the multiple of another. So that I would always say, thank you for staying through. Then try to subscribe to our channel, which is at mathmarathon_001, and then our page, which is at mathmarathon. God bless you always.